Hello everyone. Our today experiment is a Fischer esterification of acetic acid by using isoamyl alcohol. So in this experiment you will be synthesizing an ester, isopentyl acetate. It is often referred to as banana oil because it smells like a banana. So about Fischer esterification, this is an equilibrium reaction that is usually not far shifted either toward reactant or product. That's why usually we use Le Chatelier's principle to achieve the equilibrium. For that, we can do two ways. So the first is adding some reactants, and so the reaction will go to right, and or adding some other reagents to remove the product, and that will be causing the shift of the reaction to the right, and so in this way we will achieve the equilibrium. For example, in the reaction and the experiment which you are going to do today, we're going to add some extra acetic acid as one of the reactants to have the shift of the reaction to the right side to the product and to achieve the equilibrium. So we choose the acetic acid because it's the cheaper reactant. In addition, we're going to add some extra sulfuric acid. So sulfuric acid will attract the water as the byproduct of the reaction, and so by kind of removing all the water, so the reaction will go to the right, and in fact it will go to an equilibrium, and so to the products. So we will have an isolation procedure. In this process, much of the excess acetic acid and the remaining isopentyl alcohol will be removed by extraction with sodium bicarbonate and water. After drying anhydrous sodium sulfate, the ester is purified by distillation, and the purity of the liquid product will be analyzed by using IR spectrum. So about the esterification, the reaction which we're going to do today, for example, when we're going to use acetic acid and ethanol. So because we will have an acidic medial, so the proton will attack to the electrons of the oxygen, so we'll have a carbocation. So ethanol will attack to the positive center, and so after removal of the water, so we'll have our final product. But don't forget that the byproduct of the reaction is the water, and so in addition to the product, the final product, which is an ester. So, or for example, here I'm going to show that. So by adding some extra sulfuric acid, so we can remove the water, add the product. So when we remove the product, or in fact decrease the concentration of one of product, so the reaction will go to the right and we will achieve the equilibrium. So about the Le Chatelier's principle, so it will cause for the reaction to go to the right. So to have, as I've mentioned, we have two ways, two procedure. At first, we can add some extra reactant, or we can use a method to decrease or remove one of the products. So for example, for the reaction which we're going to do today, so by adding some extra some acetic acid, which is the cheaper reactant, that's why we choose this to add extra, so we will have a shift to right and having more product, achieving the equilibrium. Or another way is using sulfuric acid to remove water. So by removing the water, we will have more shift of the reaction to the right. We will achieve the equilibrium and we will have the products. So about the sulfuric acid in these reactions will serve as a stronger acid to catalyze the reaction. It will make the reaction go faster. It has a strong attraction of water, as I've mentioned, and it helps shift reaction to right by bonding strongly to the water product in the reaction. So the reaction and the experiment which we're going to do today has different with the procedure which you can see in your textbook. So we're going to use isoamyl alcohol and glacial acetic acid. However, in your textbook, they suggest to use one butanol. So here we're going to use 3 times more of the acetic acid, as I mentioned, based on the Catalier principle. So about the procedure, so we're going to do reflux. So you need to assemble the reflux system. You will have a heating mantle, the round bottom flask, the condenser. So you don't need to cover and close the top of the condenser. The top of condenser must be open. And so in the round bottom flask, you need to add isoamyl alcohol, acetic acid, sulfuric acid, boiling chip, and then adding water for having the water flow in the condenser to cool it. And so you need to do the boiling, the reflux, for 1 hour. So here, as you can see, we don't use any thermometer to control and monitor the temperature of the system, because in a reflux system, the reflux temperature will not go higher than the boiling point of the solvent. That's why we don't need to use any thermometer to control or monitor the temperature of the system. So some tips. Weighing small masses is usually more accurate than trying to measure small volumes. That's why instead of measuring of isoamyl alcohol based on the volume, you can weigh it by using balance. That would be more accurate, but you can use volume as your measuring parameter. So in addition, for measuring sulfuric acid, because you need a very low volume of sulfuric acid, it's going to be 0.4 milliliter. So maybe measuring this low volume is a little difficult. So, but I believe you know that 1 drop of liquid is usually around 0.05 milliliter. So to have 0.4 milliliter, you need to add 8 drops of sulfuric acid. That would be easier for measuring of the sulfuric acid. So after 1 hour heating, boiling and the reflux of the mixture, you need to cool the contents by using an ice bath. So after cooling the mixture, decanted to a separatory funnel. So after decanted, you need to take care about the boiling chip. They should not go to the separator funnel. So you need to add 5 milliliter deionized water to wash your round bottom flask and add it again to the separator funnel. So shake the separator funnel and then allow to have 2 different separated layer, and remove the bottom layer, which is the aqueous layer. So after removing the bottom layer, you need to add 5 milliliter sodium carbonate. But before shaking, you need to swirl the funnel to be sure that CO2, which will be the byproduct and the product of the reaction of the sodium carbonate with the mixture, will be released. And so after that, and after being sure that carbon dioxide was removed from your separated funnel, you need to cap your funnel and shake it, and allow it to have two separate layer, and again remove the bottom layer, which is the aqueous layer. The top layer is your product. So after removing the bottom layer, you need to decant your product to a beaker and add anhydrous magnesium sulfate to dry your product. So to know how much of magnesium sulfate must be added to your liquid product and dry it, you need to add magnesium sulfate to your mixture, shake your mixture, and when you see some extra powder of magnesium sulfate, it means that's enough. So at the beginning of adding the powder, so you will see that magnesium sulfate is solving in the liquid. But when you add more and more, at a point you can see that the magnesium sulfate will not be solved, and you will have some extra powder of magnesium sulfate. That's the point, which means it's enough. You don't need to add more. So after drying, you need to filter your mixture to remove magnesium sulfate powder. So you need to use gravity filtration. You don't need to use vacuum filtration. So after filtration, you need to use a 2 milliliter pentane to wash the filter paper to increase the yield of the reaction. So at the end, you need to do simple distillation. I believe based on your previous experiments, you are familiar with the distillation system. And so after assembling and doing the simple distillation, you will have your product at the end, and you need to collect it in a test tube. That was your today class. Good luck, guys. Take care.